Hello everybody and welcome to chapter 8.1 of Advanced Functions. We're officially on the last chapter of the course, so if you got this far, congratulations. We're almost finished. So chapter 8 is going to be focusing on combining different functions. So those functions will be everything we've learned throughout the course. So for example, you might be combining a polynomial function with an exponential function, or a logarithmic function with a trigonometric function. We're going to learn different ways of combining functions, how to deal with each of them, and how to graph them as well. Chapter 8.1 focuses on the sums and differences of functions. So first, we're actually going to discuss something called the superposition principle. And then we're going to talk about the profit function. Both of these concepts are actually pretty simple, so I hope you stick around and learn about that. So the superposition principle is something that states that the sum of two or more functions can be found by adding the ordinates of the function, which means the y-coordinates. As you can see, this was found a long time ago, since they're using words we haven't heard in a really long time, as well as adding the ordinates of the function to each x-coordinate of the function. So that sounds pretty simple, and we can use this property to graph any sum of functions. So first, let's look at two very simple ones. For example, if we had f of x is equals to x squared plus 4 and g of x is equals to 2x, the question is asking us to graph h of x. So first, we could rewrite, or actually write out, what h of x is equals to. So we just substitute these two values in, so we get x squared plus 4 plus 2x, and then I rearranged it into our familiar quadratic standard form. So there it is. From here, you might want to actually graph it. We know how to graph quadratic functions, that's not a problem. But the important thing to note is that although you know how to graph this function, you might not know how to graph functions like 2x to the power 7 plus log of 5. Right? You don't know what happens there. And so this principle allows us to do it. So first, we're actually going to create a little chart like this. So we're going to write out our x values. I chose 5 of them, 2 negatives, 2 positive, and 1 0. We're going to substitute each one of these into our three functions now. So for f of x, we get 8, 5, 4, 5, 8. Okay? For g of x, we get negative 4, negative 2, 0, 2, 4. Makes sense. And then lastly, we're going to substitute these values into h of x. And we get 4, 3, 4, 8, and 12. So now you can take your points, so negative 2, 4, negative 1, 3, 0, 4, 1, 8, and 2, 12, and graph the function. Once you do that, you can actually identify the key points. So first of all, you could already tell around where the 0 should be, but either way, we can try to factor it. If that doesn't work, we can apply the quadratic formula. Once we find our zeros, we can then calculate the maximum or minimum point, which remember would be your vertex. And the vertex is going to be equidistant from each of the zeros. So you could take the average of the zeros, and that is where your maximum or minimum point will be. Once you find your maximum or minimum point, you can then state the range. Pretty simple. We know how to do things with a quadratic. The most important part you have to learn is literally this graph. You need to understand that it works. You need to understand that if we were to add these two numbers together, we're getting these values here. If you add 5 plus negative 2, you get a 3. 4 plus 0 is 4. 5 plus 2, this should be a 7. Ooh, we did a goof. Let's fix it. It should be a 7. See? We could have easily mixed that up. But yeah, now that we caught that problem, genius. We have, again, just found out that it had to be that. Again, let's try this again. 1 squared is 1 plus 2 plus 7. Yep, it's 7. So that was just me writing it wrong. Either way, that was a wonderful way for us to check our answers. So yeah, remember how to add two functions together. It's just adding the points together for where they're the same. It's also an extremely important topic for you to understand, is that when you're adding two functions, they can only be added if they have the same domain. So for example, if we had a function that was defined for values greater than 0, but another function that was defined for values smaller than -1, you can't do things with those two functions because they do not have an overlapping domain. You could only do this when you have values for x that are present within both of the functions. So if you get that, we can now talk about the profit function. You are familiar with the profit function probably from way back in grade 9, but you might have not called it that. The profit function is when you're dealing with costs and revenue and of course profit. So now, instead of saying those things as variables or as basic numbers, we can express each one of them as a function. So let's look at an example where a profit function must be used. A hot dog vendor has fixed costs of $120 per day to operate, plus a variable cost of $1 per hot dog sold. He earns $2.5 per hot dog sold in revenue. The maximum number of hot dogs that he can sell in a day is 250. So A, or our bullet point 1, is asking us to write an equation to represent first the total cost, C, as a function of the number H, which is of hot dogs sold. And then B, or point 2, is asking us to create an equation to represent the revenue, which is represented by R as a function of the number of H. So let's do that. Okay, so I copy pasted our question down and now we could get to solving. So for A, for 1, we had write a total cost, so we know C of H, or we don't even have to say H in this case because it's, well, you know what, let's say it. C of H is equals to the total cost of a hot dog sold. So it's $120 per day to operate, that's a cost, and then a variable cost of $1. So we should have 120 plus 1 times H, which is H. That was really simple. For 2, we had our revenue as a function of the number of hot dogs. So our revenue, again we could say revenue of H is equals to $2.5 per hot dog sold. So 2.5 hot dogs. Pretty simple. Next, it's asking us to graph these functions. Okay, we can do that. Let's just insert a graph. There you go. We don't really need the negatives because again, we can't have negative hot dogs sold. So 120, we would for example start at 120, a straight line right through it. So we could just start something like that. This would be our C graph. Then it's asking us to graph the revenue graph on the same axes. So let's do that. Revenue would be starting at 0 and then going up by 2.5, which shouldn't be really steep, but I will make it steep for now so that we can try to get these two to intersect. There you go. It'll be something among these lines. This point here, we can find either by actually graphing these into decimals and seeing where they intersect, or we can get to it in over here, asking us where it breaks even. So either way, we graph the functions, pretty easy. Next, again, identifying the break-even point. The break-even point would be where our cost is equals to our revenue. So see, we have cost of H is equals to R of H. So then 120 plus H is equals to 2.5 H. 120 is equals to 1.5 h. So h is equals to, let's calculate it. $80. So we break even at 80 hot dogs, which would mean that when we have 80 hot dogs, our costs and our revenues are the same. We can figure out what that value is. So again, let's just substitute into one of these functions. I really like this one's because, so for example, C of 80 is equals to 120 plus 80, which is equals to $200. So then we could say that when the vendor sells 80 hot dogs, he his costs and his revenues are the same at $200. Next, it's asking us to identify the domain and range of this function. Oh wait, actually we missed one part. It's asking us to define the profit function. So what is the profit function? Well, luckily for us, it is saying what it is. It is equals to R of H minus C of H. We can now substitute our values in for each of these and we get 2.5H minus 120 plus H, which is equals to 1.5H minus 120. It is then asking us to graph it. Either way, we could do that. It'll be going from negative 120 and then it's going to be going up by 1.5. Should be even less steep than that guy over here. So it's going to go like that. When we do this, we are actually finding very crucial information about this function, which we will discuss in a little bit. So, lastly, or second lastly, it's asking us to talk about the domain and range of each of the parts we just discussed. So, first of all, we had C of H. So C of H would have a domain such that H could be any whole value. We can't have half a hot dog being sold or a negative quarter, right? We need whole positive numbers. And then our hot dogs, as said in the question, cannot be more than 250 because I'm guessing he buys only 250 hot dogs. So our first domain would be something like C of H is H is an element of all whole positive numbers, which I'm pretty sure is a 0, like a Z, and then 0 small graded to H, large graded to 250. So that is the first thing we have. Our range would be from our smallest value, which is 120, towards whatever 250 times r times 1 is. So we have 120 plus 250, so our domain was this, and our range would be C is an element of all real numbers, such that 120 is smaller than C, smaller than 370. There you go. So for our revenue, we're gonna go through the same process. Still, the hot dogs can't have half a hot dog, so that's good. Again, we can't sell more than 250 hot dogs, and we can't sell negative hot dogs, so our domain would stay the same. So R of H would be the same as the guy we had up top. Let's see if I can copy him. There you go, that's good enough. Then for our range, we need to again now discuss what values is our lowest. Well, we're starting at 0, so we have to have that R is a number such that from 0 to 2, it would be 250 times 2.5, which is 625. There you go. Lastly, we have our profit function. We graphed it over here. the domains will always be the same, right? No more half hot dogs, no more than 250 hot dogs in total. So again, we could just copy paste that. For range, we're actually going to be starting at -120, so -120, and then we're going to be going all the way until we get 1.5 times 250 minus 120, which is actually 255. So this is profits to 225. Now, our last question is, what is the maximum daily profit that the vendor can earn? So the way we could figure it out is if we just substitute the amount of hot dogs we can sell for max value, 250. We substitute that in, and we already found out it's $225. Therefore, our answer would be that the maximum daily profit is $225. Either way, as you can see, a lot of this process was something you had done in grade 9. It is just adding a constant, for example here, to a variable, and then here is a multiple of a variable. Like, it's very simple stuff. The only reason why we have to go over this is so that you understand how we can derive functions from a real world process. Understanding that will allow you to solve much more complex questions, because then once we start talking about substituting functions into another function, you will not be getting the hang of it unless you understand simple functions like these. So yeah, overall, that is all that this chapter has for us. So as we go back to our homework page, I've assigned 6 questions for today, but sadly 12 and 17 will be long. They are word problems with multiple steps within them, so if you feel like it's a little bit too much, I'd recommend just doing, actually, let's change it to 18. I'm looking at the textbook right now, let's make it to 18. Come on. There you go. So yeah, I'd recommend just doing 18 and also like the first 3 or 4 of these, because they're going to let you understand the superposition principle a lot more. But yeah, either way, I hope you have enjoyed chapter 8.1. It's still a little bit on the easier side, but it will get harder in the future. 8.2 is already talking about multiplying and dividing functions, so that should be really fun to do. Either way, I hope I will see you for that lesson, but if not, if you've enjoyed this class, or if you had any questions, please leave a comment down below. I'll always be happy to help any of you out. But yeah, either way, thank you so much for watching this video, and I hope to see you next time. Bye bye!